As in the previous video, split the work area into two parts. As you can see, first principles to show why the shortcut method works. Now this one here is counted as a complete group, so we have to be very careful when dealing with that. We want to get the group on its own, so we need to get rid of the 5. Now, as I explained in the previous video, there's your 88. Take the 5 over to the other side. So move the number first, then think about the sign. It is plus on the left. You do the opposite action when you move it across, so it becomes minus. That will leave you with 3 over 4 times A. First principles. 3 over 4 times A. Now, plus 5. So we're putting that in there. To change this here such it has no effect, we change it into 0, so we're putting nothing back into there, and we do that, we put it in, so we take it out. The net effect it's like switching a light on and switching it off. You end up in the dark still. So that is indeed the case there. So we have the 88, and because we remove 5 from the left, we remove 5 from the right. That gives me 3/4 A. I'll put it in plus nothing, alright, so that doesn't do anything. Minus 5 is 83. Yes. So this here is 83, and we end up with 3/4 A. So you can see that and that are indeed the same thing. The shortcut method, use that, it's quicker. It works because of this. Alright, now we've got to separate out the A, because the objective is to have one A on its own on the left of the equals and a number on the right. So we need to get rid of the 3/4 on the left. If we have, for example, say 103, and I multiply that by 1, it doesn't change it, it's still 103. So multiplying something by 1 has no effect on its value. If I can change that to 1, it has no effect on the A. In other words, it's the same as having A on its own if I change that to 1, which is what we do over this side. Shortcut A. What we do, take it over to the other side, there's your 83, except we turn it upside down, 4 over 3, okay, and we multiply there. That is the shortcut. You'll see why now. I'm going to put, let me get rid of this. I am going to put the 3/4 in a bracket. There's your A, there's your 3/4. Right, the bracket only groups things, it doesn't alter very much at all. It's still multiplied by A equals 83. This is exactly the same in value as that. To change that into 1, I multiply it by the same thing but turned up the other way. Fancy word for it is inverse. Because I've multiplied the left by that, I have to multiply the right by that. This becomes 1. Not written, but there's a times there. equals. Now look, if you're not sure, look, 83 times, let's use the fraction, shall we? 4 over 3. Come out the fraction, we get this. My calculator, when it does that, it means the 6's go on forever. 110. So in this case, A is equal to, did I say 110? Yes. 110.6666, and they just go on forever. The thing is about when you have 6's like that, that is the same as 2/3. 3, 3, 3, 3 is 1/3. So 6, 6, 6 is double that, which is 2/3. A is equal to 2/3. Let's test it, shall we? 3/4 times A, we're going to substitute now, times 110 and 2/3 equals, now let's have a look, shall we? Let's clear that lot. Come in here. Oh, fraction 3 over 4. Come out the fraction, multiply it 1. Hang on a minute. No, got to be very careful here when using the calculator. I'm going to put a bracket in there. 110 put with the fraction 2/3. Come out, close the bracket, and we get 83. But I have not added the 5 yet, so I now go plus 5, and we get 88. So that indeed works. Quickly running over it, isolate the group that has the A in it. So you've got rid of everything else apart from the group. Split the group up so you end up with A on its own, or X, or whatever variable you want.